In this video, we'll be going over a break-even analysis problem with the time value of money. The problem states that the Cooper company is considering investing in a recuperator. The recuperator will have an initial cost of $20,000 and a service life of 10 years. Operating and maintenance costs for the first year are estimated to be $1,500, increasing by $100 every year thereafter. It is estimated that the salvage value of the recuperator will be 20% of its initial cost, and the recuperator will result in an equal annual fuel savings throughout its service life. Assuming MAR is 12%, what is the minimum value of fuel savings for which the recuperator is attractive? So the first thing you want to do is to gather all those numbers in an organized manner on the left side. And then we can calculate the salvage value of the recuperator by multiplying the initial cost by 20%, which you get $4,000. And then given all those numbers, we can now create a cash flow diagram and also let X denote the minimum value of fuel savings. As mentioned earlier in the break-even analysis introduction, we know that total cost is always equal to total revenue. And so here we can calculate the annual worth with a MAR of 12%. So the first thing you have is to subtract $20,000, which is the initial cost, and multiply it by this value where you'll find the annuity given the present value. Subtract $1,500, which is the first year operating and maintenance cost. Subtract $100, which is an increase of $100 every year thereafter, and multiply that by the value which you find the annuity given the gradient. And finally, you'll add $4,000 for the salvage value and multiply that to find the annuity given the compound amount, and add X to the whole equation. If you refer to the back of the book, you'll find the values, which are 0.177 for the annuity given the present value, 3.585 for the arithmetic gradient, and 0.057 for the annuity given the compound amount. And there you can simplify your equation. So now we can get the break-even value by setting the annual worth equation to 0. And so we'll single out the X and put everything else on the right side of the equation. And there you get $5,170.50. So that's the example for break-even analysis with the time value of money.